So the big picture for this lesson is modeling projectile motion and fallen objects. So this function is for an object that is dropped or falls. H of t equals negative 16 t squared plus h sub 0. H sub 0 is the initial height. That's a constant, so that should be given to you in the question. And then the time is your input, and the height as a function of time is the output. Let's say someone drops a rock into the Grand Canyon. I would not recommend this for safety reasons, by the way. And let's say that particular cliff has a height of 1,500 feet. So 1,500 feet straight down. That's your initial height. Then you want to know what the height as a function of time is. Well, let's write the function. Okay, so next thing we're going to do is we're going to graph this on the calculator. Need to adjust the window. You can see it looks like two vertical lines basically, but I know it's a parabola. I know the initial height is 1,500, so my max should be up there, my y max. So I'm going to put 1,600 just to allow a little extra room. Okay, that's a nice looking parabola. So this is height, the vertical axis, as a function of time. This is not the path of the rock. Somebody didn't throw it and have it fall this way. It's dropped, and this time increases, the height decreases. And that's a key point. And so if you wanted to find the time it took for the rock to hit the ground, you could just calculate the x-intercept. So I can calc 0, left bound, and then I'm going to move to the right of the 0. And I can tell up to the right because the y value went negative. Okay, 9.68. So it would take 9.68 seconds for the rock to hit the ground, and that's ignoring wind resistance, of course. Okay, now for a projectile, that's something that's thrown up in the air. You still have the initial height, that constant, but there's another constant, the initial vertical velocity. In other words, that's the vertical component of the velocity as the object is thrown up in the air or launched up into the air. Like a rocket tends to go kind of straight up in the air. So that would be all vertical, but sometimes things are launched like a cannonball or something, maybe launched as diagonal, but you'll be given the initial vertical velocity. But the modeling works exactly the same way. So let's say your initial vertical velocity is 20 feet per second, and your initial height for the projectile is 5 feet off the ground. So your launcher is 5 feet off the ground. Here's what your function would look like. And then you could graph this function on your calculator, and then you could see both what the maximum height of the projectile is and how much time it would take for the projectile to hit the ground. Those are usually the two interesting questions about projectile motion. But I'll leave that to you. That's the big picture for this lesson.